Today we're going to start looking at explicit sequences. Now, before we actually begin into explicit sequences, we need to understand what some of the definitions and terminology mean that we're going to see when we're solving these. One of the terms you're going to see is arithmetic. And arithmetic is formed by adding a constant each time, which is called the common difference. So you're going to come across some problems that are just going to ask you for the common difference of a sequence of numbers. And that common difference is basically what are you adding each time to get to the next number. So this first set, these are arithmetic. We basically want to figure out what we're adding each time. So to go from 11 to 9, we had to add a negative 2. To go from a 9 to a 7, we had to add a negative 2. And to go from a 7 to a 5, again, we had to add a negative 2. So the common difference, which is usually represented with a d value, your common difference is negative 2. Okay, basically, what are we adding each time? This time we're adding a negative 2. With this next set of numbers, again, we go through our common difference this time as we actually added 2. And go from 17 to 19, again, we added 2. So this one has a common difference of 2. Again, common difference, basically, if you see the word arithmetic, it's basic linear type of things. We're just adding a certain number each time. Sometimes it's positive and the numbers are going up. Sometimes it's negative and the numbers are going down. But your common difference is that number that you're adding each time to get to the next one. If you need anything from this screen, go ahead and pause the video and remove screens. Alright, the other word that we need to know when we're dealing with sequences is geometric. Geometric is formed by multiplying a constant each time, which is called your common ratio. So when we look at these numbers, for example, that first one, 1, 3, 27, we're definitely not adding the same thing because from 1 to 3 it's only 2, and it's not 2 to go from 3 to 27. So it's not arithmetic, this is geometric. These we're trying to figure out what we're multiplying by each time. So to go from a 1 to a 3, 1 times what basically gives us 3. We multiplied by 3. And to go from a 3 to a 27, we multiplied by 3. So this one has a common ratio, which is represented with an R, common ratio of 3. Our next set, to go from a 16 to an 8, or an 8 to a 4, again, we're trying to figure out what we're multiplying by. Now, if you notice, our numbers are getting smaller, so it has to be a number between 0 and 1, and numbers are getting smaller. So what we're doing is we're multiplying by 1/2, which again is the same thing as dividing by 2, but in sequences it's always what are you adding and what are you multiplying. So multiplying by 1/2 is the same thing as dividing by 2. So as well as I go from 8 to 4, we're also multiplying by 1/2 or halving it, so that means my common ratio is 1/2. So some of your homework questions are going to give you sequences and just say what's the common ratio or what's the common difference, and you're just going to be typing those numbers. If you need anything from this page, go ahead and pause the video. Alright, so for example, just like ones you're going to see in your homework, it's going to say, for these two, it says find the common difference. Again, your common difference is you're finding what you're adding each time. So we're looking from 3 to 0, from 0 to 3, from 3 to 6. Every single time we are adding 3 to get to the next number. So that means my common difference is just a 3. In my next set of numbers, I'm going from 15 to 11, 11 to 7, and 7 to 3. So in these ones, we're adding negative 4 each time. Again, adding negative 4 is the same thing as subtracting 4. A lot of students see it that way. So every time I'm adding a negative 4, so that means my common difference is negative 4. Okay, if you need anything from this screen, go ahead and pause the video. Alright, now the other times when you're looking at numbers, instead of a common difference or an arithmetic, we're going to be looking at a common ratio. Common ratio is what you are multiplying each time to get to the next number. So if we look from 7 to 14 or 14 to 28, each time that we're multiplying by 2. So it means our common ratio, again represented by R, is going to be a 2. We're multiplying by 2 every single time. Now on this one, to go from 20 to negative 10, or from negative 10 to 5, or 5 to negative 5 halves, basically we are multiplying by negative 1/2 because our signs are changing each time. 20 times negative 1/2 is negative 10. Negative 10 times negative 1/2 is a positive 5. So in this one, our common ratio is a negative 1/2. Basically, if you see a common ratio that's switching signs, going from positive to negative, positive to negative, positive to negative, your common ratio is negative, because negative times negative is a positive. That's where those positives starts coming out. Again, if you need anything from the screen, go ahead and pause your video. Alright, so you have one problem in your, well, one or two, I can't quite remember, problems in your homework where it's asking you guys to find the next number in the sequence. So really, all you have to do is just figure out what's happening each time. So for this one, it looks like we're adding -3, and same thing for there, we're adding -3 each time. So if we take 8 and we minus 3, we get 5. Take 5, we minus 3, we get 2. If we take 2 and we minus 3, we get -1. So in your homework, you're going to have blank places there that you just want to type in the correct number as the sequence continues. But again, it could be a common ratio or a common difference, so just kind of figure out with those first few numbers what you're adding each time or what are you multiplying each time. That'll help you find the next numbers in the sequence. If you need anything from this, pause your video. Alright, so now we're going to get into the actual explicit formula versus just finding common difference and common ratio. Now the explicit formula, what it tells you is it allows you to find any term in a sequence. So, for example, you might have a sequence and it says, what is the 50th term of the sequence? Well, you're not going to want to continue that sequence 50 times to figure out what that 50th number is in the sequence, or you could have a short sequence of numbers that says, what's the 75th term? Again, you're not going to want to do that 75 times, your common ratio, your common difference to find it. So your explicit formula that I'm going to show you here in a second, it's kind of scary when you first see it for students. They don't like the notation. It's kind of big. It's got a lot of parts to it. But your arithmetic and geometric explicit formulas honestly are not too bad. They're basically set up the same way. It's just kind of getting used to your notation to it. So if you need anything from the screen, pause your video. Okay, so this is the arithmetic. And I'm going to circle, this is just the function. I probably should have just wrote the function out first. That's the arithmetic explicit formula. And like I said, it's kind of scary when you first think about it, when you first see this thing, because it's kind of crazy looking. But this first term right here, that a sub n, that's how you pronounce that, a sub. Instead of an exponent, it's at the bottom, so it's a sub. A sub n means the nth term. So like if we're trying to find the 5th term, we'd write A5 equals. Or if you're trying to find the 15th term, it'd be A15 equals. So don't let that a sub n really mess with you. It'll just have that notation. So if you're trying to find a certain term, that's all you have to write to it. This next part, a sub 1, that's just your first term. When you look at your sequence number, the first number, whatever that first number is, that's the number that goes right there. Right here is your common difference. So we just went through finding common difference, so that should be something easy to find. And this last part is the previous term. It basically just means it's one less than whatever you have here. So if you're trying to find, let's say, the 15th term like I had over here, if I'm trying to find a sub 15, I would have had a 14 right here because it's one less than the one you're trying to find, which will probably make a lot more sense when we look at those problems. Alright, so if you need anything from the screen, go ahead and get it. And we're going to look at the geometric as well. Alright, geometric sequence. Again, I probably should have just wrote the equation and then added to it, but that's the geometric explicit formula. And if you notice, it's very, very similar to the last one. It starts out with the nth term, except for it's a g now because it's geometric. So it starts out with the nth term, whatever term you're trying to find. Your g of 1 is your first term in your sequence. And really the only difference we see now, other than the g instead of a, is right here. What you have, right there, what you have is a times, because in geometric you're multiplying to get your next number, whereas in common difference you were adding. So arithmetic, after you have that first term, it's either plus or times, depending on if you're dealing with arithmetic or geometric. And this one wants your common ratio, because again you're dealing with geometric. And it's an exponent, your n minus 1. So, again, very, very similar setup to them, just whether you're multiplying or adding, and then the n minus 1 is either next to it or it's up above if it's an exponential. So if you need anything from this screen, go ahead and get it. Alright, so we're going to go through and actually try to find our certain term to it. So we're going to start using these formulas a little bit. Now, I'm going to show a little extra work. Oftentimes students will find these answers pretty quickly using their calculator or so, but I want you to know where the numbers are coming from, so you don't have to write all this notation every time, as long as you can find your number. So the first thing we want to do is we want to look at this and see what kind of a sequence we have. Are we adding something each time, or are we subtracting? Going from a 1 to a 4 and a 4 to a 7. Hopefully it's pretty easy to see that we're adding 3 every time. So this means I have a common difference of 3. So now I'm going to start doing my arithmetic. So my explicit arithmetic function is a of n equals a of 1 plus my common difference and then n minus 1. So we are looking for the 20th term, so this will be a of 20. Again, that a sub n, that's all that means, is just telling you which term you're basically trying to find. A sub 1 is your first term. Well, the first term in our sequence is a 1. So 1 plus our common difference, which is 3. So 3. And then it's n minus 1. Now, honestly, I would save the trip. Your n minus 1 is 1 less than what you're trying to find. We were finding the 20th term, so we plug in a 19 right there. And most students just plug this right side of the equals into their calculator. 1 plus 3 times 19, which gives us 58, pretty sure. Let me double check just to make sure. Yep, it comes out to 58. I just wanted to make sure on my notes there. But that's it. So in order to determine the certain term in a sequence, again, don't get so distraught on your formula. If you can recognize just the pattern of what you're doing, you're basically just going to take, I'm going to change colors here in a second, take your first term plus your common difference, and then in parentheses behind that, 1 less than what you started with, and just solve. Alright, so I'm going to do another couple examples of these. So hopefully they'll start making more sense. So if you need anything from this screen, go ahead and get it. I'm going to pause this, or I'm going to switch screens. Alright, so this one we're going to determine the 30th term of the sequence. Again, we have to determine what's happening each time. Are we adding something each time, or are we multiplying by something each time? So in this one, I'm going from negative 10 to negative 15 to negative 20. So I'm adding a negative 5 each time. Oh, my negative's not showing up. There we go. So that means my common difference is negative 5. So now we can start doing our formula to it. So again, our formula is going to be the term we're looking for. So a of 30 is equal to my first term in the sequence, which is negative 10, plus my common difference, which is negative 5, and then in parentheses behind that, 1 less than what you started with. So we want the 29th to fit in there. So our a of 30, or our 30th term, is negative 10 plus negative 5 times 29, which is going to give me negative 155. And if you need anything from this, go ahead and pause your screen. We're going to look at one more arithmetic, and then we'll start looking at some geometric ones. Alright, so for this one we're going to look at the we're going to look for the the 50th term of the sequence. So again, I just got to figure out what's necessarily happening each time. So on this one, to find my 50th term, I'm going from 100 to 92, 92 to 84. So in this case, I am adding negative 8. Or again, you can think about it as the fact that you are subtracting 8 each time. So we're looking for the 50th term. So a of 50 is equal to our first term, which is 100, plus our common difference, which is negative 8. And then in parentheses, 1 less than what you started with, so 49. So to calculate our 50th term in our sequence, we have to do 100 plus negative 8 times 49, which in this case gives us a negative 292. So that is the 50th term. If we were to keep this thing going 50 times, we would end up getting negative 292. Alright, we're going to look at one more arithmetic and then we'll do some geometric. So if you need anything from this screen, pause your video. Alright, so this one is determine the 15th term of the sequence. So again, we have to go through and figure out what are we doing each time. This one I went from -2 to 0, 0 to 2, 2 to 4. So I'm adding 2 every single time. And so we're looking for the 15th term of this arithmetic sequence. So again, it's going to be our first term, which is -2, okay, plus our common difference, which is 2, and then one less than what we started with, which is 14. So our a of 15 is -2 plus 2 times 14, which gives us 26. So if we were to continue the sequence to the 15th term, we would find that it ends at 26. Okay, so we're going to stop looking at arithmetic ones and start looking at some geometric ones. Again, the setup to it's going to be the same. You're going to start off with your first number, and then instead of your common difference, you're going to have your common ratio, which is a multiplication. And then your one less, or n minus 1, is an exponent for this. So if you need anything from the screen, go ahead and get it. Alright, so this one we're going to determine the 10th term of the sequence. Now, 10 isn't very far, so some students find it easier just to go to the 10th one. But sometimes geometric ones get really, really big or really, really small, so I didn't want to go too far on these. But again, we got to figure out what's happening each time. So we're going from a 3 to a 6 to a 12. So hopefully we see that we are multiplying by 2 every single time. So our geometric series, our sequence, sorry, I'm just going to write, since this is the first geometric, I'm going to write the original formula to it. It would be g of 1 times r to the n minus 1. So we are looking for the 10th term, so g of 10. G of 1 is my first term, which in this case is 3, times my common ratio. In this one, my common ratio was 2. That's what we were multiplying by each time, so 2. And the exponent is going to be 1 less than what we started with. Well, we started with, or we wanted the 10th. This is to the 9th. And again, most students just type that in their calculator. 3 times 2 to the 9th, which comes out to 1,536. So again, you kind of notice these numbers get big really, really fast because it's exponential. So I usually don't ask you for one that's really far from where we started with. So that's a geometric. Again, it starts with your first term times your common ratio, and then our exponent is whatever term we're looking for minus 1. Alright, so we're going to look at 2 more. So if you need anything from this screen, go ahead and get it. Alright, so we're going to determine the 15th term of the sequence. So again, we're going to have to figure out what's happening each time. When I look at the sequence, I'm going from a positive 1 to a -2 to a positive 4. So automatically I know I'm multiplying by some sort of negative because it's switching signs. So in order to go from 1 to -2, I had to multiply by -2, and to go from -2 to 4, I also had to multiply by -2. So that means my common ratio is -2. So we are looking for the 15th term of the sequence, so g of 15 is equal to my first term, which is 1, times my common ratio. Now, any time that your common ratio is negative, like our common ratio is negative, because you're going to put an exponent to it, it needs to be in parentheses. So it's going to be -2, and your exponent is 1 less than what you wanted, so to the 14th. So our g of 15 is going to be 1 times -2, and just make sure your -2 is in parentheses, -2 to the 14th, which is 16,384. Again, your numbers get pretty big pretty quick with these. Alright, so we're going to do one more geometric, and then I think you'll be ready for your homework. So if you need anything from the screen, go ahead and get it. Alright, last question. So again, we want to find our geometric, or in this case, we want to find our 18th term of this geometric sequence. So we got to figure out what we're multiplying by each time. So this one looks like I'm multiplying by 3 every single time, so my common ratio is 3. So in order to solve the 18th term, I'm looking for g of 18, which is my 18th term. So I'm going to start with my first term, which is 3, times my common ratio, which is 3. My exponent is 1 less than what we were looking for, so 17. So our g of 18 And you can just type that in your calculator, 3 times 3 to the 17th. If you notice, I didn't put the R value in parentheses this time because it's not negative. I don't have to. This one comes out to a really big number, so I'm going to write it down here. This is 387,420. Oh, sorry, 387,420,489. So like I said, these geometric ones get pretty big, so I usually don't ask you to go too far with them. But hopefully that helps and makes sense.